In this lesson we're going to look at the conservation of momentum. This states that providing no external force is acting on the objects involved, then momentum is always conserved in both a collision, for example, as in this case where you've got two carriages coming together, or in an explosion, such as these two cases where the objects are flying apart from each other. Okay, the momentum is always conserved. So let's just state that law here is conserved in collisions and explosions. So those are the two types of dynamic situations that you might come across in your GCSE, IGCSE exam questions. Okay, let's look at the collision here for a start. So we've got two carriages, one of mass m1 and another mass m2, and they're moving towards each other. So we have this one travelling with velocity v1 and this one travelling with velocity v2. Okay, and what we can say first of all is the momentum of this situation, just spell it out, is equal to p1, that's for carriage 1, plus p2, that's for carriage 2, which is equal to m1 v1 plus m2 v2. And the law states that their momentum before the collision is equal to the momentum after the collision. So in this case you can see they've stuck together and the momentum is now m1 plus m2, and we'll call this v3. So we'll put those in brackets, multiplied by v3. And the law of conservation of momentum says that these two momentums are equal. Okay, so let's change this into a typical physics problem. We'll give some figures to the situation. Let's say this carriage weighs 50 kilograms and is travelling at 10 meters per second, while this carriage weighs 30 kilograms and is travelling at, now here we've got to be careful because notice that it's travelling from right to left, so the velocity is now negative. Right, so we need to put, let's say it's travelling at 6 meters per second, so we need to write v equals minus 6 meters per second. Right, that's important there. No, you must be aware of the positive and negative velocities in these situations, and the things stick together and move from left to right. So we want to find out v3, and so the two trolleys stick together, and what we want to find is with what velocity they then move. This is a typical sort of problem. So we plug these values into our equation now. We have 50 times 10 plus 30 times minus 6 equals 50 and 30 are 80 times v3, which is what we want to find. That gives us 500 minus 180 equals 80 times v3, and if you sort that out, that gives you 320 divided by 80, which will work out as 4 meters per second. Now the velocity is positive, again emphasizing that we're moving from left to right. All right, so we've calculated the velocity of the combined trolleys. Okay. Now again, another situation where this conservation of momentum law is applied is where we have an explosion rather than a collision, where things are flying apart. Okay, for example, you've got a gun which is firing a bullet, and the bullet will move to the right and the gun will recoil and move to the left. You know, that could be a cannon, it could be kind of many different types of explosive situations. For example, again, somebody jumping off of a boat is exactly the same problem. The person jumps this way right, moving in that direction, and the boat recoils and moves in the opposite direction. Okay, let's just look at one of these situations. Look at the situation with the old-fashioned gun here. So we have the gun has a mass m1, the bullet has a mass m2, the gun recoils with a velocity v1, and the bullet is fired with a velocity v2. And so what can we say about the momentum in this situation, where it's an explosion, is that the momentum before the bullet is fired is equal to 0. So before anything's fired, the momentum is 0, everything's stationary. Then the momentum after the bullet is fired, well, we can say that we have m1 v1 plus m2 v2. Okay, summarize that. That's the momentum before is equal to the momentum after. Okay, and we can make some sense of that by applying figures again. Let's just say that the gun weighs a kilogram and the bullet weighs, say, again 50 grams, and the velocity of the bullet is 300 meters per second. So we want to find out what is the recoil velocity. So we substitute these values in. We have m1 times v1, which is m1 is 1, so that's v1, plus m2, which is 50 grams. Remember, you've got to change that to kilograms, really important, is 0.05 kilograms times 300. 0.05 times 300 is 15, is equal to 0. So that means that v1 is equal to minus 15 meters per second. So what you've got to do, you've got to understand what that means. So if we're saying that v1 is equal to minus 15 meters per second, that means that the gun is moving from right to left. In other words, it's recoiling, which is what we'd expect. Okay,